Ionic equilibrium, few conceptual questions. O2 minus 2 is the conjugate base of. The question is very simple. If you remove hydrogen in the form of H plus, if it is formed, okay, then that is the actual acid and it is the conjugate base of that one. For example, if you see this one, if you remove this H plus, it will become O2 minus 2. From this, if you remove, it will become HO2 minus. From this, if you remove, it will become OH minus. You are removing H plus. From this, if you remove, it will become O minus 2. Correct? Weakest conjugate base is obtained from. Weakest conjugate base means that must be from strong acid. From strong acid, weak conjugate base is formed. It's an organic acid, weak acid. It is an organic acid, weak acid. HTS is again weak acid. So comparatively strong acid is HNO3. So NO3 minus is weak conjugate base. Correct? Next question. Which of the following is not a conjugate acid base pair? To be conjugate acid base pair, there should be only one proton difference. You see here, hydrogen, it is not there, charge increased. Two hydrogens, one hydrogen, charge increased. Two hydrogens, one hydrogen, charge decreased. Sorry, three hydrogens, so charge decreased. Here you see two hydrogens, no hydrogens. That means here two hydrogens are changed. Conjugate acid base pair means only one proton difference should be there. So this is your answer. In aqueous solution, HCl and HNO3 are equally strong. This is because not only HCl, HNO3, any acid if you take, all acid strength is equal in water. This is because of leveling effect of water. It is known as leveling effect of water. All acid strength is equal to H plus ions of water. All base strength is equal to OH minus ions of water. Fine. Coming to the next one. Which of the following acts as Lewis acid? To function like Lewis acid, there should be vacant orbitals. Vacant orbital is present in which of these? So that is sulfur, boron, okay na, helium, hydrogen if you take. Boron can also function, but only boron generally doesn't available. Boron is highly reactive, boron is available in the form of different. But sulfur is possible. Sulfur is possible and sulfur is having vacant orbital, so sulfur is the best Lewis acid here. BF3 is Lewis acid, BCl3 is Lewis acid, and only boron is generally not available. Which of the following is a Lewis acid? To be Lewis acid, there should be vacant orbital. BF3 is having one vacant orbital with boron, so this is the Lewis acid. CCl4, no vacant orbitals with carbon. H2O, no vacant orbitals with oxygen. Sulfate, it is already superoctet type. Okay, na? So it is again not a Lewis acid. Which of the following acts as Lewis acid in the following reaction? SnCl4, Cl minus. Cl minus is functioning like here, electron pair donor. So tin chloride is accepting Cl minus. So this is Lewis acid. It is Lewis base. He is asking about Lewis acid. So Lewis acid is SnCl4. This is one very interesting question. Group 13 elements you see this question generally. Which of the following is relatively strong Lewis acid? Actually, in terms of Lewis acid, there is no word strong. Okay, na? Hard acids, soft acids like that. The meaning is in BF3, boron and fluorine are of almost same size. Because of this reason, fluorine can give the electron pairs back to boron. This is known as back bonding. So that back bonding is maximum in case of BF3, then BCl3, then BBr3. Back bonding is minimum in BH3. That means boron is with vacant orbital in BH3 much possible. BF3, BCl3, BBr3, BH3. In all the molecules there is a vacant orbital, but in BF3 the back bonding is maximum because boron, fluorine both are of same size. then BCl3, then BBr3, finally we have BH3. Fine. This is one very important question. Okay, BH3 is your answer because here back bonding is very less. Which of the following is not a Lewis acid? Lewis acid means it must have vacant orbital. NH4 plus, no vacant orbitals. NH3, no vacant orbitals. So this is your answer. Tin can have vacant orbitals. So tin is a Lewis acid. Which of the following is a Lewis acid? Again, to be Lewis acid, it is silicon tetrafluoride because it has vacant orbitals. Here you can see carbon, oxygen. These are of second period, no vacant orbitals except boron. H2S, H2SO4. You can't take this because they release H plus, so they are arrhenius acids, or you can say Bronsted Lowry. To be Lewis acid, vacant orbitals. So SiO4 is best option. In a complex compound, ligand acts as. Ligand means electron pair donor. Electron pair donor is Lewis base. Aluminium plus 3 is a Lewis acid because it has vacant orbital. Direct definition. Okay, after 27 we have completed. We will go with more than 100 questions. So stay tuned. This is your lucky sir. అడగకపోతే అమ్మాయినా పెట్టదంటారు. ఓకేనా? సో అందుకే అడుగుతున్నాను. సబ్స్క్రైబ్, షేర్, ఎక్కువ మందికి రీచ్ అవ్వాలని మన కోరిక అంతే. యూట్యూబ్లో డబ్బులు వస్తాయని కాదు కానీ. ఓకేనా? గాట్ మై పాయింట్. యూజ్ అవుతుంది అనుకుంటే మీ ఫ్రెండ్స్కి షేర్ చేయండి. డన్. థ్యాంక్ యూ గైస్. సైనింగ్ ఆఫ్ లక్కీ సార్.